So this one is a video for Integrated 2 Math Analysis. I'm calling this one RFF number 6. This is the one that says special for our Integrated 2 honors class. So on this one, they are asking us to find the value of x. Now you need to remember for a 45, 45, 90, okay. Again, those are the same. So in the 45, 45, 90, here, let me draw it a little better so I can get my 45 in here. So 45, 40, 45, 90. Pretend that looked like a 90. If this is well, let me put it in. If this is x and this is x, then this is x root 2. So if this is 5 and this is 5, then this x is 5 root 2. So we want it as the exact, not as a decimal, which is what you would get if you were using trig. Okay, so on this one, we want to find the value of the variables in the parallelogram. So first off, this y here is in a triangle. Okay, so here, let me do this. Here is this triangle. So I'm going to go 180 minus 23 minus 112 is equal to y. And let's see, 180 minus 23 minus 112 is 45. So this is going to be 45 degrees is my y. Okay, so now I know that this is 45. Now, in this situation, I do have some parallel lines. So let me get this a little lighter. Okay, so I have this parallel line. I'm going to kind of extend it and make it a little lighter. And make it a little fatter. Okay, so I've got this and this parallel line, and it's cut by this transversal. And so I am going to have this angle here and this angle here are going to be the same. So I'm going to have x is going to equal to 23 degrees. And it's because of alternate interior angles. Then I also have my z. So for that one, let me just make this a little fatter again. Okay, so this time I've got this parallel line, and again, here is my transversal. And I know that in this case, that if this angle here get my color here, sorry. I know that if this angle here and this angle here are the same, so this has to be 45 degrees. And again, we know that this was 23 degrees. So we have to have this one right here being 112. So I know my z is going to be 112 degrees. And what happens in parallelograms is opposite angles are congruent. So when I saw 112 here, I know I also am going to have 112 here. Okay. On number 3. Okay, so at McDougal's Giant Hot Dogs, 15% of the workers are under 18. The most desirable shift is 8 p.m. and 80% of the workers under 18 years old have that shift. 30% of the workers who are 18 or older have the 4 to 8 p.m. shift. What's the probability that a randomly selected worker is 18 or over and does not work the 4 to 8 p.m. shift? That's A. And then B, what's the probability that a randomly selected worker from 4 to 8 shift is under 18 years old? Okay, so I'm going to set up an area model. And actually, I think I'm going to do a tree diagram for this one. So for this, I am going to start with knowing that 50% of the workers are under 18. Okay, so I'm going to have 0.15, write that better, 0.15, and this is going to be under 18. And then that means that 0.85 is going to be greater than 18, or equal to, okay, because it's everyone else. And then let me get another color. It says here that the most desirable shift is 4 to 8 p.m. and 80% of the workers under 18 have that shift. So 80% of the workers that are under 18 have the shift from 4 to 8, which means 20% don't. Okay. And then over here, for people who are over 18 or 18 and older, 30% of them have the 4 to 8 shift, which means 70% don't. I decimal down a little bit. Okay, so I'm just going to compute these, and what I'm going to be doing, let me just kind of, I'll highlight it and then I'm going to take it off. So what I'm doing when I'm going to do this multiplication, I'm going to be taking 0.15 times 0.18. Then I'm going to be taking 0.15 times 0.2 and so forth. Okay, so when I'm doing 0.15 times 0.18, so 0.15 times 0.8, I get 0.125. So here I'm going to get I don't need that faint anymore. 0.12. And then when I'm going to be doing the 0.15 times 0.2, 0.15 times 0.2, I end up getting 0.03. So this is going to be, let me get rid of those lines though. 0.03. And I'm going to do the same with the other branches. So 0.85 times 0.3 is 0.255. I'll put the 0 in front. And then 0.85 times 0.7 is 0.595. So in this question, it says, what is the probability that a randomly selected worker is 18 or over and does not work from 4 to 8? So that answer is going to be right here. So this is going to be 0.595. Now, the second part of this is asking, what is the probability that a randomly selected worker from 4 to 8 p.m. shift is under 18 years? So I want to be looking, so I know that, what I know, let me just highlight what I know. So what I know is that, so it was probably that I randomly selected a worker from 4 to 8 p.m. So I'm looking at workers from 4 to 8 p.m. And so my 4 to 8 p.m. workers, this and, yep, sorry, this and this are my 4 to 8 p.m. So that is who I'm looking at. So I am going to be taking 0.12 plus 0.255. That's going to be my denominator. I'm looking at those people. And out of those people, what's the probability that they're under 18? So then I'm looking at, just shade, I'm looking at, these are, whoops, I'm going to shade in yellow. These are the ones that are in that category. Out of those two, 0.12 are the ones that are under 18. So now I'm going to put as my numerator 0.12, and I'm going to put this into my calculator. And when I do, I end up getting a 0.32. So again, the number here on the bottom is the two yellows that I circled in the first one. It's the two ways that I can have anyone working from 4 to 8. Then that's my denominator. Now, out of those two, 0.12 are under 18. Okay, so this is another mouse one, rat one. Okay, so we want to know what's the probability that he ends up in section A and section B? Which room is he more likely to go into? Okay, so for this, starting here to here, this is going to be a 1/2 and a 1/2. And then from here, I again have a 1/2 and a 1/2. So let me just do the math here for these. So this end here is going to be a 1/4, 1/2 times 1/2. This is going to also be a 1/4. Okay, so now the next thing I'm looking at is going here and here, which is another 1/2. Just put a dot there, and a 1/2. So this one here is going to be a 1/4 again. Now, let's say I put a dot here, and then I have these two, so I have another 1/2 and another 1/2. Now, when I'm computing these, this one is going to be my 1/2 in pink times my 1/2 in blue times my 1/2 in red, which is a 1/8. Same with this. So now for my, if I'm looking at my B, let's say I'm looking at B. So my B, let me circle in yellow. This is B, this is B. So I am going to be taking 1/8 times 1/4, and that's going to be, if I get a common denominator of 8, a 1 plus a 2, so that's going to be a 3/8. Now for A is going to be these ones I'm circling in green. So this 1/8, this 1/4, this 1/4. So I have 1/8, 1/4, 1/4. Again, I'm going to get a common denominator, which is 8. So I'm going to have a 1, a 2, a 2. This is going to give me 5 out of 8. So the one that is more likely to happen is A. Okay, on number 5. I'm multiplying imaginary numbers. So when I multiply imaginary numbers together, I can do an area model. 3 plus 4i, 9 minus 2i. I end up getting a 27, a 36i, a negative 6i, and a negative 8i squared. Now, this negative 8i squared, what you need to remember is an I squared is equal to a negative 1. So that means that this is really going to be an 8. Okay. So this is going to be a negative 8 times a negative 1, which is 8. So now I'm going to combine like terms. So I'm going to have my 27 and 8, my 36i and negative 6i. So I'm going to get 35 plus 30i as my answer. On number 6, okay, so I have a parallelogram, and I know ON is 8x minus 7, LM is 6x plus 2, NM is x plus 5, OL is 3y plus 6, and we want to find the values of these. Okay, well, I know that 8x minus 7 has to equal 6x plus 2. So that's going to give me 2x is equal to 9. So x is equal to 9 halves, or 4.5. Sorry, I didn't mean to move that. Okay, and now I'm going to be taking these two, this one here and this one here, and I know that they equal each other, and so I know that this is a 4.5 plus 5 because I just got that answer for x, and these two things need to be the same, so I'm going to have a 9.5 equals 3y plus 6. I'm going to minus 6, and I'm going to get a 3.5 equals y. And when I do that, sorry, equals 3y. Oops. Equals 3y. And when I do that division, I'm going to get that 1.16 repeating is equal to y. Okay, on number 7. We want to find the perimeter, and we want it in simplified radical form. So whatever is across from your 30, if you double that, you get your hypotenuse. Whatever's across from your 30, if you times it by root 3, that's what it is across from your 60. So I am going to get 9 plus 3 root 3 as the perimeter, because I'm going to add the 6, the 3, and the 3 root 3. Okay, so I know that this line and this line are parallel, and we want to find AP. Okay, so we want to find AP. I'm just going to call that X, so I have something to put there. Okay, so when I have something like this, I can use the side splitter. So I can say X over 8 is the same as 9 over 12. Cross multiply, 12x is equal to 72. So x is equal to 6. And again, I use side splitter. Number 9. 9. I can use Pythagorean theorem. So I'm going to go x squared plus 4 squared equals 7 squared. So x squared is equal to basically 49 minus 16. So x squared is going to equal 33. So x is equal to the square root of 33. And 3 and 11 are the only numbers that go into it, and they're not squares, so it's simplified. Okay, so I have an isosceles triangle. Whoops. A, B, C. I know that this is 3x minus 7. This is 2x plus 16. And this is x plus 9. And so since this is isosceles, and we know that these were the legs, and BC is the base, we know those have to be equal. So I'm going to take 3x minus 7 is equal to x plus 9. So I get 2x is equal to 16. X is equal to 8. So for 11, what I can do is, since it is a negative exponent, and a negative exponent flips, is the reciprocal of whatever you get when you raise it to the positive of that power, I am going to write it like this. I'm going to flip this, 4y, 3x to the 5th, y to the 4th. Now it's raised to the positive 2. And so I'm going to get 16y squared on top, temporarily, 9x to the 10th, y to the 8th, and I am going to clean that up. So 16 over 9 I can't clean up, but I have 2 y's on top and 8 y's on bottom. So my x to the 10th is going to stay, and this is going to become a y to the 6th. And that's your answer. On 12, I know that this angle is equal to the sum of these because of exterior angle equals sum of 2 remote interior angles. So 4x minus 25 is going to be the same as the x plus 3 plus the 2x plus 7. So I'm going to get 4x minus 25 equals 3x plus 10. So x is equal to 35. And that's x. They wanted me to find angle C. So C, measure of angle C, is equal to 35 plus 3, or 38. On number 13, we know DO is 10, OG is 14 in a triangle, and we want to know what has to be true about DG, the other side, the third side. So I'm going to subtract these and get a 4. I'm going to add these and get a 24. So I know that DG, the measure of DG, has to be between 4 and 24. So on number 14, let's see. So I know that since this is isosceles, that this angle and this angle are the same. And so I know that if this is 110, this has to be 70, which means y has to be 70. So this is also going to be 70. And then I know that if I take 180 minus 70 minus 70, I'm going to get x. And so 180 minus 140, x is going to be 40. So I have 40 degrees and 70 degrees. On 15, circle the correct answer. The diagonals of a parallelogram always bisect each other, are congruent, are perpendicular. And these are they bisect each other. The diagonals of a kite are always parallel, congruent, or perpendicular. They are going to be perpendicular, so it's going to be C. The diagonals of a rhombus are always parallel, congruent, or perpendicular. And this is going to be that the diagonals are going to be perpendicular. On 16, we're going to find x with the angle. This is going to be opposite. This is hypotenuse, so I'm going to be using sine. So I'm going to do sine inverse of opposite over hypotenuse. That is going to be what x is. And when I put that in my calculator, I get a 36.87 degrees. So that's going to be A. And that's the end of this video.